Hi guys, and happy holidays. If you're new to CNC, chances are you're probably feeling a little bit overwhelmed. I get it. There are so many new terms, tools, and processes to learn, it's easy to feel like you're in over your head. But here's the good news. You don't have to figure it out alone. In this video, we're going step by step through this simple CNC project, all the way from the design process to the cutout. I'll explain each step in plain language and share all the small details that make a big difference. If you stick around to the end of this video, I'm going to tell you how to get Vcarve files and toolpath files for this build for free. When you're done watching this video, you're going to be armed with all the information you need to make your first cut. Let's dive in. So now we can talk about the design, and starting off, there's a couple of things I want you to know that's important to being able to design in your CAD, your computer animated design software. And that is knowing the difference between a raster and a vector. This is going to be very important. So I'm going to open up my CAD software, Vcarve Pro, and I'm going to create a blank document. And I'll create it the same dimensions that our project is going to be. So that's a width of 7 inches, a height of 12 inches, and a thickness of 0.75. That's our canvas, and what I'm going to do is download an image so I can walk you through this process. So there's two different kinds of file formats. There's vector files and there's raster files when you're dealing with CNC. Raster files are pixelated images. They're made up of tons of tiny little boxes. And because of this, they have a resolution. You'll see a resolution with a raster image. Generally, you want to find something that has at least 1,000 by 1,000 resolution size to be able to trace it good in your CAD software. Anything smaller than that, when you scale it up, because it's a raster, it's not infinitely scalable, and you'll start to see fuzzies because you're starting to see those pixels show up. This is in comparison to a vector, which is a format that uses mathematical formulas to define points, lines, and curves, and it's infinitely scalable. It has no resolution. You can blow it up as big as you want, and it'll maintain its properties. And that's what CNC likes to deal with. It likes to deal with vectors. So if you download a vector, you're already good to go. You can import it into your CAD software. If you download a raster, that's fine, but you're going to need to trace the image in your CAD software and turn it into a vector so it can be recognized by the CNC. So I'm going to show you here, we're going to download raster image and then we're going to trace it together. See, this resolution is 840 by 859. That's not exactly what we want, but I'm going to show you this just for demonstration purposes. So the first thing we want to do is go up here and hit our import vector button, and we'll click on import raster or vector. We'll import our raster, and there it is. So we have it clicked. Now we want to go to this button that says Trace Bitmap. And there's different ways you can do this. You can trace it in color, or you can trace it in black and white. Sometimes, if you don't have a great image, you can use color to trace it a little bit better. That's kind of beyond this video right now. We're just going to trace it in black and white so you can see what it looks like after it's traced. So hit the preview button, and it gives you a preview of what it looks like. You can play around with the settings a little bit to get a better trace. We're going to hit apply and then close. So now we can delete our background image, and that's what you're left with. So it traced the image for you, and now it's in vector format, which means if I go to scale it, it's infinitely scalable now. And now I can create my toolpaths based off of that vector. So now I want to open up our actual project, and this is our vector image. And I wanted to point out raster images are easier to find on the internet for free. If you want to get a vector, usually you're going to have to pay $1.99, $2.99 for an image, but it's worth it. You get to keep it and you can use it an infinite amount of time. So I found this vector online, I bought it, and I imported it into the CAD software. So a couple of things I want to talk about for the design and the toolpaths here and how we start this job out. So on this page, this is what's going to open up when you first open your CAD software, and it's going to have a couple of things listed here. It's going to have job size, it's going to have Z0 position, XY datum position. That's all you really need to worry about for now. For job type, single-sided, that's what you're going to be starting off with. Double-sided is something totally different. As you get more advanced, you can get into that. Job size. So our job size has a width of 7 inches and a height of 12 inches and a thickness of 0.75 inches. Then we're going to set our Z0 position. And what this is it's telling the machine where our start position is for the job. So if this is our material here and we're zeroing off the material surface, we're telling our machine that the material surface as opposed to the spoil board surface or the material bottom is going to be our Z position. That's where we're going to tell our machine that's the start point. For XY datum position, this is telling the machine again where the start point is. So if we're doing material surface XY position, it's going to be right here. And when we go to zero our machine, when we're setting up our actual project, I'll talk more about this. But I like to use the bottom left corner for my XY position. So material surface, bottom left corner, that's all set. Now we hit OK. So we have our job set up. So we're going to be using a Vcarve toolpath and a profile toolpath. To do that, we need to do some things to this design to make it easier to set up these toolpaths. So I'm first going to delete this and I'm going to delete this. So this is our starting image. This is the image of the Grinch and it's just one layer. The problem is when we go to create our Vcarve toolpath, if I was to highlight all of this and say I want to do a Vcarve toolpath, it's showing you that this is what the job would look like. And you can see these areas here is where it's cutting all the way through the material. It's cutting way too deep. It's just a mess. That's not what you want. As opposed to, we're going to clear that out. So this toolpath is the one we've set up, and we're going to preview that. And so you see, now that's giving us our Vcarve cutout, and it's giving us what we want. It's giving us basically a trace of the image so that we can go in later and fill that in with black paint through our ore mask. But in order to do that, again, like I said, we need to have 2 lines to be able to do that. So going back here, turning it back to 2D view, we need to add another line to the outline of this. And for that, we're going to do an offset. So there's a button here called an offset. And what we're going to do is offset it outwards. So it's going to be outwards of this line, and it's going to be 0.1 inches. We'll hit the offset, and that gives you this extra line. So now when I go back to do my Vcarve job, that's all highlighted, and it's going to cut in between these lines. That's how Vcarve works. So this is showing you where the CNC is actually cutting. It's cutting in between these lines that we've set up. And I'm going to show you the parameters that you need to set in order to make this toolpath. So you highlight your vector, and then you go to the Vcarve toolpath button. And this is what opens up, Vcarve Engraving Toolpath. So for this, you want to first set your tool. And for this, we're going to use a 90-degree Vbit. And you'll see a number of different tools here. Do yourself a favor. Whatever company you buy your Vbits from or your end mills from, they're going to have a master database that you can download online that will import into your CAD software. And I'll show you how to do that on a separate video. But I use Amana tools, end mills. They're really easy, and I've imported their master tool list into this. So I have the Amana tool 90-degree Vbit, and because I've imported the tool list, it automatically calculates the feeds and speeds. So you can see the feed rate of 30 inches per minute, the spindle speed of 18,000 RPMs. Feeds and speeds is how fast you're telling the bit to move and how fast the spindle is moving to give yourself an optimal cut based off of that bit. And it can get pretty complicated, and that's probably one of the harder parts of CNC. So I recommend when you're starting out, you pick a tool set that you like. Amana Tools works great for me. You import their master tool database, and then you have the feeds and speeds automatically set in for these feeds and speeds. That's a good place to start off. As you learn more about feeds and speeds and want to set your own, you can do that manually. But For now, we've chosen our V-groove 90-degree V-bit. Feeds and speeds are automatically loaded. I'm going to hit apply, and that'll import your bit and your feeds and speeds. That's really all you need to worry about with the Vcarve toolpath. You want to name it something that you're going to remember in the CAM software. I've labeled mine Vcarve 90-degree tool 3 because in my CAM software I have to know the tool number. Then you hit calculate, and it's going to calculate the toolpath. So now that we've created our Vcarve toolpath, we want to create our profile toolpath. And our profile toolpath is going to be basically cutting out this image entirely from the wood. It's going to cut all the way through the wood so you can have your 3D Grinch piece come out of the wood. To do this, we need to set another offset, because if I were to tell the machine to cut a profile toolpath right here, let me show you what would happen. So let's set up a profile toolpath, 0.75 inches deep, and I'll talk about these numbers in a minute, but I just want to show you. This is what it would do. So you see, it would cut out right at the edge of your Vcarve toolpath, and that wouldn't look very good. We want a little bit of a border here between your Vcarve toolpath and the edge of where it's going to cut out. So I'm going to delete that. And what we need to do to be able to get that profile toolpath is create another offset. So we're going to go back. We're going to click on the outermost vector line, and we're going to create another offset. So for this, we're going to go another 0.1 outwards. And now we have another offset. So we can go to our line, click on it. That's the outermost line is what we want to cut. And we're going to click on the profile toolpath. And once you're in here, you need to tell the machine what to cut for this profile toolpath. So we've already told it that our wood thickness is 0.75 inches deep. We need this to cut all the way through the wood, so we're going to set a cut depth of 0.75 inches deep. For our bit, I use a down cut spiral bit. 46415K is the down cut spiral bit. That's a 1/4 inch diameter. It has a 1/4 inch shank. Shank is the diameter of the base of the tool that fits into your CNC's collet. Most CNC collets will be a 1/4 inch and a 1/2 inch. Sometimes some of the beginner machines will only give you a 1/4 inch collet, so you have to be wary of that. So when you order bits, you make sure you order them with a 1/4 inch shank. And again, because I'm using Amana Tools master list here, the feeds and speeds is already set. Our feed rate is 70 inches per minute. Our spindle speed is 18,000 RPMs. We can hit apply. And then we can calculate that toolpath. We'll reset our preview. It shows you it's cutting all the way through the material. And now using both toolpaths, you can see now we have the profile cut out on the edge, but we have this nice little border between our Vcarve toolpath and our profile toolpath. So that is how you set that up. I'm going to delete this because we need to talk about one more thing, and that is we've set our cut depth to 0.75. We've picked our bit. We need to tell the machine how many passes we want to make. So if you have a 3/4 inch thick material and you're doing 3 passes, it's going to take off a 1/4 inch of material at a time. That's the most aggressive you want to get. You never want to take off more material than the diameter of your bit. And I like to go even less than that most of the time. For this, we don't need to, but if you want to err on the side of caution, take less than the thickness of your end mills. Maybe do 5 passes here, and that'll give you a lot less material taken off per pass than 0.25 inches. And you would just say 5 passes. Cut pass depth 0.15 inches. I'm going to leave it at 0.25 inches for now. It's 3 passes. So this area right here is very important. This tells us, are we cutting on the outside of the line we've selected? So this outermost line here, are we cutting on the outside of that? Do we want to cut on the inside of that? Or do we want to cut directly on the line? For a profile toolpath, with you cutting the whole piece out, you're going to want to cut on the outside of the line. So make sure the outside is hit. And you can see from our preview that our machine is going to cut on the outside of that outermost line. So that's set. Now we want to do something very important called adding tabs. So if I were to cut this piece out without tabs, there's nothing holding the workpiece. So the second it cuts all the way through, the piece is now unsecure and it has the potential to fly off and hit you in the face, which isn't good. So we need to add some tabs so that the piece is held to the rest of our workpiece, which is being held by our eccentric clamps. So to do that, we'll go into Edit Tabs, and we want to put, say you want 6 tabs. So you'll up this number to 6. You'll hit Add Tabs, and these little yellow boxes will appear. That's where your tabs are going to be. And you'll see these green lines. That's showing you where the edge of your tabs are going to be. So at that point, you would hit Add Tabs, and it's going to add the tabs for you. The length of your tabs is 1/4 inch. The thickness of your tabs is 0.125 inches. Now that those tabs are added in, and we recalculate our toolpath, you can see that now there's tabs in the workpiece, and that's going to hold our workpiece secure. So make sure you're adding tabs to your workpiece. Once that's done, then you can name your profile toolpath. I like to name it outside hole, the name of the tool, and then again, I'm numbering the tool because my CAM software needs me to do that. And then we hit calculate. So now that we have our toolpaths created, we're going to save our toolpaths. So I'm going to click on this outside hole profile toolpath first, click on the save button. And you'll see here it says post processor. And this is important because this is what's going to take your toolpaths that you've created in your CAM software and turn it into the specific G code for your computer animated manufacturing software. And based on what software you use, your post processor is going to be specific to that CAM software, so you have to put in the right one. For me, I'm using Avid EX control in inches for my Avid CNC, and it's going to turn that into G code specific for my CAM software. So I have that selected, then I can hit Save Toolpath. Save these toolpaths to a location where you won't have difficulty finding them. And again, I'm going to have a little short segment at the end of this video where I tell you how to access these toolpaths, these 2 toolpaths, and the Vcarve file for free. Then we'll do the same with our second one. Make sure the post processor is selected, save toolpath, save it to a location you remember. And that's it. Our design is set, toolpaths are set, our G code has been created. We're all set to go prep our workpiece, put it into our actual CNC machine. I'll talk about Workholding, and then turn on our CAM software, home our CNC machine, zero our bits, put in our bits, and then start our actual job. So for materials for our actual project, this prototype that I made in pine. But I noticed some things that I didn't love about it that I'm hoping making the project in hardwood might fix. And that is, if you get really close in on this, you can see that there's kind of some little chip outs, and that's because pine is a soft wood and it doesn't hold its edge quite as well as hardwood. So I'm hoping if we do this with hardwood, we'll get a better result. But again, you can choose to either use pine or hardwood, whatever you have available. You are going to tell your CAD and CAM software what size your project is. And based off of this design, we're using a piece that's 7 inches wide by 12 inches tall. So we need to cut this so it's 7 inches wide and 12 inches tall. And that way it'll line up with what size our machine thinks it is. Now we have our piece at the correct dimensions, length, and width. We need to make sure it's the correct thickness. And what we've told our CAD CAM software is this is going to be a 3/4 inch thick piece of wood. If you're going to be into CNC, I highly recommend you pick up yourself one of these. There'll be a link in the description. These are thickness calipers, and these let you know exactly the thickness of your material. So we're just going to check and make sure we're good. And that says 0.755, and that is close enough for this project. If you haven't already, you might be wondering how we got the paint inside of these lines. It would be very difficult to paint by hand unless you're like an artist, which I am not. To do that, we use something called Oramask, and I'm going to show you how to set that up in a minute. But in order for the Oramask to stick properly to your project, we need to sand this first with 80 grit, then 120 grit, then 220 grit sandpaper. That final 220 grit sanding creates a really smooth finish that your Oramask sticks really well to. Now that you have that all sanded, take a tack cloth and just wipe down the surface. You want to get off any dust so the Oramask will stick well. And then we can put on our Oramask. So for this, you're going to need your Oramask, and again, link in the description for this. You're going to need a knife with a fresh blade in it, and you're also going to need one of these. So first thing you're going to do, size out a piece of your Oramask. And then cut that. Set your Oramask aside. And you want to peel back one corner. All right, so you have one corner peeled back. Then what you want to do is peel this away from the edge so you have about 2 inches of the Oramask exposed, and then the rest of it's in a roll like this. And what you're going to do is place your Oramask down on one end. Take your card scraper and make sure that that end is properly stuck. Then you're going to take the other end and you're going to slowly roll it out, flattening as you go. To make sure there are no air pockets. Perfect. Now that you have it on and secure, cut the edges. Good. Then come back with your card scraper and just give it a good rub down to make sure it's really sealed against the wood. Perfect. So now we've reached the point where our project, our materials are all prepped, they're ready to go, and we need to talk about work holding. So I'm going to show you my work holding technique, and then I'm going to talk about a few other options for you, and then I'm going to refer you to a video I've already made about work holding solutions that you can check out after this video if you're interested in learning more about different work holding options. So for me, I've built a custom spoil board, and it uses these quarter 20 bolts with an Allen key top to them, and quarter 20 nuts that are underneath the table that accept the bolt. So what I do is I take my piece, I secure it in the corner, and you want to make sure when you're first setting up your CNC that you have a nice square corner guide rail if you're going to do this method, because you need something to secure the piece to. So now I'm going to take my bolts, place them in, lock them down. One there, and one there. All right, those are locked down. So I recommend you always have a ton of thin scraps handy if you're going to use this work holding method, because you're always going to need pieces to shim. So these are eccentric knobs, which means they get slightly bigger as the knob progresses, so it can tighten down against this workpiece. But you may need to put something in to give it enough to clamp to. So that looks perfect right there. All right, make sure it's flat against your CNC top. That's not going anywhere. That's one work holding method. You can also use T-track. You can use painter's tape and CA glue. You can use vacuum hold table. Those are certainly more advanced and a lot more expensive. And again, check out the video I've made before on 5 work holding solutions for CNCs. It's a really great place to start if you want to learn about work holding. I'm excited because we're finally ready to start opening up our machine and doing some actual cutting. So the first thing we need to do is open up our CAM software. So this is the home page for our CAM software, and that stands for Computer Aided Manufacturing. The first thing we need to do is run a homing cycle, and what that's going to do is tell the machine where the starting position is. It tells the machine where is its home position, where is its jump off point. To do that, I'm going to hit the homing button, and now it's going to zero out the Z, X, and Y axes and tell the machine where the home position is. So the machine is now homed. You saw that message pop up that says the machine is homed. Next, we need to tell the machine where the starting point is for our job. And to do that, we want to load up a Vbit. In this case, I'm loading up a 90-degree Vbit. It's the Vbit we're using for this job. And we need to load up a Vbit so we have pinpoint accuracy on where we're telling the machine the starting point of the job is. For zeroing your X, Y, and Z axis, remember when we first opened up our CAM software, we let the machine know where we wanted our Z point to be and our XY point to be. That was the bottom left corner and the surface of the workpiece. So now we need to jog our machine so that the tip of our Vcarve bit is just touching the corner of that position on our workpiece. And then we need to go to set part zeros, and we need to zero out the X, Y, and Z axis. So that tells the machine that that corner, that exact position, is where the job is starting. Now that the machine is homed and we've set the zero position, all we need to do is load the G code and we can get to work. So I'm going to load the first toolpath, which is the 90-degree Vbit toolpath, load that G code into my CAM software, and then all we need to do is hit the go button. Now that that Vcarve toolpath is done, we need to change our bit so we can do the profile toolpath. And then we need to tell the machine that we've changed the bit, and that is because when you change the bit in the machine, the height of the bit changes. So the machine now needs to know where the tip of that new bit is so it can correctly predict where the surface of the workpiece is now based off the tip of that bit. So all we need to do on my machine, you hit a manual tool change load program, and what that's going to do is go over and touch the bit off zeroing platform, and that's going to tell the machine that what the height of the new bit is. On newer machines, you're going to have something called a probe touch plate, most likely, or you can just manually zero the tip of the bit to the machine. Now that we got the project all cut out, we need to remove it from the clamps, and then we need to remove the tabs that we put in to make sure the piece didn't fly off at us while we were cutting. So we'll take these out. Piece is good to go. With these tabs in there now, there's a couple different ways you can remove them. You can use an oscillating tool. You can use a jigsaw. I prefer the oscillating tool, so I'm going to take my oscillating tool and I'm going to just cut these tabs. So now we're over at our router table, and what we're doing here is the tabs, we need to clean those up with a flush cut trim bit, and then I'm also going to add a little bit of a round over to the back side with a bit. That's a step if you have the bits in the router table, you can definitely do. If you don't, you can skip this step. If you want to remove the tabs without a router table, you can just sand them down. So, little things. This is a hard bristle brush, and I use this all the time on my CNC projects. We just made our Vcarve cuts, and there's some fuzzies in here, so you just take your hard bristle brush and you just get those fuzzies out. Cool. Once you're happy with that, you're now going to fill in the lines with your black paint. And I'm just using black acrylic paint. This is paint you can get at any hobby store. You can get it off online too. Now we can take our aura mask off, and I'll show you an easy way to do that, and then add our red, white, and green acrylic paint. The easiest way that I've found to remove the aura mask on this is with a razor. And you just come in at the corner, lift it up, and then peel. And as promised, guys, I want to tell you how to get the free Vcarve file so you can get access to the Vcarve design and also the toolpaths. What you want to do is go into the comment section of this video and comment free Grinch CNC file, free Grinch CNC file, and then I will message you back a discount code that you can then use on my website. Website link is in the description to get the file for free. So take what you learned today, make your first cut, and remember, CNC gets easier and more fun with every project you try. If you enjoyed this video, check out this video next on 5 CNC work holding solutions. Thanks for watching.